Welcome back, folks. I hope you had a good lunch. Now we'll be having lightning talks where each speaker will get 5 minutes to hopefully you'll learn something from here. So now first up we have Akash Sil.
Hello. Yep. So, good afternoon, everyone. My name is Akash. I am senior software engineer at Subex. So, what I present to you is one of my personal project, which I have been working on for some time. I call it vGit, as the name. It's a terminal-based Git visualizer. So why exactly vGit and what exactly it is? So say you want to use Git. There are only two options. One is you can use a UI-based interface, which can be your, let's say, VS Code or Git desktop, or the normal Git CLI. In my time, whenever I'm mentoring new joinees, I have come to realize that many of them don't actually understand what Git is or how it works. For them, it's like four-step process. It's like an algorithm. You do git add, you do git commit, you do git pull, git push. And sometimes it interchange, so they get merge conflicts. And we'll take simple, like they don't know the difference between, let's say, a git fetch versus a git pull, git commit versus git amend, rebase versus merge. So my aim is I want to provide a CLI-based tool such that they can use the CLI, but it will also show what Git is doing. And hopefully in that they will, it's like a training wheel for Git, so that once they are confident enough, they can just switch to your basic CLI. So I'll just give a demo. It's a Python package. You have to do pip install vgit. As of now, it's not published in Py repository. You can just clone the GitHub repo and use pip install e with the repository. So I'll just do. So let's say normally we do git status. So if we do vgit, it divides in two columns. The below is your whatever the natural git output is, which will also be retained previously. And the upper one is a visualization. Let's say if you see in committed, it's showing one and down arrow. Means one of my commits in the remote is higher than what I have, which basically means I have to do a git pull. Let's say before a git pull, I'll do a git fetch. Okay, something broke, so we'll move on to the other example, skipping this. So apart from that, we have git commits. So if I do git, one sec. So these are I just maintained the last three, and it shows how a git is basically a branch in the end. So it's create a new head. And if I just compare it to our normal git amend, so now what you actually see is people think git amends updates the last commit, which is not entirely true if I just replay because what git does is it pops the changes in your last commit, moves everything to staging. Your changes are currently already in staging. Based on that, it creates a completely new commit and generates a new hash also. So again, people just think it's just replaceable, but that's how git internally works. How this project works is, it's again two-part. I'm using Curse's library of Python to generate the CLI animations. And I'm using Git Python to get the real-time porcelain features. What I mean by that is, what are my current status, the hash. Right now, I'm just maintaining top 4 letters and below message. So yep, in short, that's my project. It's, let's say, it's kind of in a prototype space. So how can you help? One is, again, as I said, it's a prototype phase. So one would be just using the application, and I'm open to a lot of feedbacks. I know there are issues. We just found one. So GitHub issues is there. And apart from that is, actually, I'm looking for maybe contributors, because as we know, GitHub is like very huge. They are like, in Git commits, you get 10, 20 flags, each work in a different way. So it would be good to have few contributors. And how you can connect with me is, this is my GitHub, LinkedIn. And if you are looking for, yeah. So this is the GitHub ID of the project. So I just made everything public yesterday. Thank you, everyone.
Does it has to be turned on or something?
Project.
Okay, HTML. Okay, this one works. Awesome.
Yeah, nice. Okay, thank you, Akash. Up next is Tushar.
Hey everyone, I am Tushar Mittal. I am a cloud engineer at FICO, and I love to explore open source projects and any new projects that are on the run and the trending GitHub repos. And I just like to play with them. And today I'll be covering the topic untangling the spaghetti. And it means how do you start to understand large code bases, so you can start to onboard them and start contributing to them. So let's dive right into it. Here's a temporary sample code base that I'll be trying to understand. It's Agno. It's a framework that can help you build AI agents and everything around it. So the first tool that I'm going to introduce is DeepWiki. I'm just going to copy my GitHub repo and just going to paste it into the DeepWiki. The thing DeepWiki does is gets all of the files from that GitHub repo, it puts them into a rag, and it generates me very detailed documentation around the repository structure, how the different modules or the different parts of the code base interact with each other. As you can see, it also generates me really good mermaid diagrams of how the different interaction of the code base actually tied together, and also it also refers me to the code base, the exact same source file that it used for generating those exact same, let's say, the mermaid diagrams or the references. So the thing is, DeepWiki will help you provide a very high-level overview or a high-level abstract about how you can understand the code base and give you a beginner understanding of how someone can onboard a new project. But let's dive deep into, let's say you have already decided that you have a particular module that you want to contribute to, and you want to understand the blast radius and the interactions that that particular module does with all the other code base files. So for that, we have something called CrabWiz. So you might have worked with something called PyCon graph or any other Go implementation. So those specific tools only work for a single language, but CrabWiz, being a VS Code extension, what it does is it hooks into your LSP server. So any LSP server that VS Code supports out of the box, CrabWiz will support it. So just dive right into the code base. Over here, I have my Agno repository already cloned. And what I want to understand right now is how do the OpenAI model actually interacts, how the implementation for OpenAI actually works. So what I'm going to do is I'm just going to go ahead and select the folder I want to generate the graph for, and select all of the different files that I think may be interacting with it. This is just, you can check the imports of a single file, and that will really help you understand what are the other files. I'll just go ahead and click on CrabWiz, generate graph, and right now what you'll see is a complete graph is being generated. There are 11 modules, and we're right, it's trying to generate it, and let's just wait for a few seconds before it does. Okay, so here we have all of the interactions. So what CrabWiz does is it checks for each module the inbound calls, the outbound calls, and it interacts, makes corresponding modules as well, and it generates this whole graph. The thing about this graph is you might be thinking it doesn't make much sense because there are a lot of lines going inside and outside. the beauty of it is you can zoom into it and you can check a particular function. So let's say I wanted to make my modifications into the messages.py file. Now, I just clicked on the module, and now all of the inbound calls are represented by the green, and all of the outbound calls are represented by blue. And let's say if I want to edit a specific function called toFunctionCallDictionary, I just click on it, and what you'll see is the crab is actually points me to the exact same function. I can just click on go, and it will exactly point me to the exact same function definition. So I can easily go ahead and edit it. So yeah, these are the two tools I wanted to share with the community that may be a bit unknown and may help you or anyone else who is a beginner to the GitHub or the whole community and wants to understand a new project. You can make it work for private repository as well or internal projects as well. And I think so. I'm out of my time, and that's all on my end. If you want to connect, please feel free to scan the QR, and I'll be just right down here in case if you want to have a chat. Thank you.
Thank you, Tushar. That was very crisp. Now we have Pavan and Manas.
Yep. Hello, ladies and gentlemen. I am Manas, a developer at Quadrant. So basically, what exactly Quadrant is? Quadrant is a vector database and a vector search engine, and we are the complete pipeline for the storage, for the search, and the cloud part. So basically, Quadrant is based on Rust, and in Rust, we trust. And Quadrant is an open source vector database, and that way, it is highly customizable. So Quadrant is one of the best choice for the use cases like RAG and every other systems, AI systems. So the major thing in AI applications and everything in GenAI is retrieval. So retrieval, the Quadrant deals with that seamlessly and in a very smooth manner because it's based on Rust. So the performance is very high. So you cannot expect. So we deals with storage part, as I mentioned. We deals with high advanced searches. And we deals with the Quadrant cloud systems. And for more features, over to Pavan.
Hi all, how's the vibe till now? Okay, so coming to the features part, so we do have, of course, like Quadrant supports out of the box multiple features from the vectors and the different dimensionality perspective, but most important them are the hybrid search. You can actually combine different combinations and start generating your the permutation combinations of it, like dense parts or two different dense, and then you have the late interaction models. You can do all the permutation combinations and then put it and then create your own applications on top of that with respect to your retrieval accuracies. And apart from that, like we do have re-ranking mechanisms. We do have the quantizations out of the box supported, like you can quantize the vectors, bring them down, and then start putting them into your Quadrant vector space, and then we can start retrieving out of them. So with that, let's go into the couple of use cases. Yeah, so since already Manas has told us, like it will be very much useful in the RAG space, but just not from the RAG space. I just wanted you to do a live demo where we would be showing a small product that we are doing as a prototype. And of course, as an open source community, we always request you to come forward and then contribute to us. Okay, I think now if you see it, like what is happening is basically like when I'm talking. So there is a secondary memory that is being listening to us, and it's being recorded. And then it's being sent back onto the Quadrant database. So how is that happening? So if you see that I'm wearing one device, which is called OMI, and then we have a backend, which is actually connected, and then it's listening to us. And then why do we need this? Reason for that, I can actually forget what I spoke. and later in time, I can go back and ask my memory system saying that, what did this happen today? And then I get all my retrieval back saying that, okay, at this moment in time, you were speaking at this conference stage on this particular topic. So this acts like a secondary memory without your knowledge. That's all. And then maybe I can show you here now. Maybe retrieval stopped. Another bug. Okay. So, but that's how it is. And thanks for looking at the demo and all. Thanks.
Thank you. Up next, we have Tushar.
Yeah, hey, so my name is Tushar. Then I'm going to talk about a feature in Python 3.14. So last year I came up here and I gave a sneak peek of Python 3.14, which was like it was like a prank lightning talk. Like it wasn't actually a sneak peek of 3.14. This one is a real sneak peek of 3.14, and like there's a new like a feature coming up in 3.14 that I'm really excited about called T-strings or template strings. So like hopefully most of you would be familiar with f-strings. Like, has anyone here used Python before f-strings were a thing? Okay, a bunch of people. Like, so all of you know how much like f-strings simplified writing Python and like working with like strings in general. It's like so much more ergonomic, and it like looks prettier, and it's like simpler to work with, right? So T-strings are like trying to like take the idea of an f-string and trying to make it like a lot more versatile. The idea, then like let me basically like show you with a few demo snippets. So we're gonna run this snippet. Like we all know how the regular f-strings work. They're like simply put the values of the variables where you want, then it generates a string. The return type of an f-string like expression is a string. For a T-string, that's not the case. You get a template object, and this has like a few parts. It has strings and it has interpolations, which we can kinda take a look at if dynamically. So we have this template object which has the strings, which is a tuple. It has the parts. So these parts get separated into the strings, yeah, like including the white space and everything. This gets like preserved as the string part, and then there is the part that is the like the interpolations. And what are the interpolations? Yeah, so it is also a 4 tuple. It contains things like the value, the variable name itself, the format spec, and then some other things. Like let me actually like add some format spec here so that we can see how that looks. Yeah, so the format spec becomes part of the template string as well. So you can basically get programmatic access to this template that you just created. And what that gives you is like essentially you can do things with it and get this information before you actually turn the template into the actual string. So you have the original template, you have the variables that the user passed into them. Now you can do things like validation in between. So like for a basic demo, like if you have a template like this, you can kind of iterate over it, then you get the parts of it in the correct order, in the sense that Uh, 2.5. 2.5. There we go. Yeah, so we get it's like a string type first, the my name is part, and then the then we get the interpolation object, then we get the string, the interpolation, and then the string. So it gives them us back in the correct order if we try to iterate over the template object. And let's try and turn the T string back into an F string. The output is back again to what we had in the beginning. So we're like not doing anything extra. How do we do that? We create a function that goes over the template and it recreates the string parts that we created. How do we do that? Like if we get a string part, like we simply keep it. If we get an interpolation, we run the built-in format function. We take the value out and then like we pass it the format spec so that it does the correct thing. But what we can do is validation on top. Like you can restrict the age to be like greater than 0. So like in the regular case, we get the normal string, but we can add validation within your template where we catch bugs. So that's kind of the idea. I'm out of time, but yeah, that's all for me. Thank you.
Thank you. Now we have Chaitanyam.
Good afternoon, everyone. Quick disclaimer, this talk is going to be slightly different to all the talks that you have heard so far. And it'll probably also explain what a company like, agriculture company like Kotava AgriScience is doing in a tech conference like PyCon. So to set the context, I'll take a minute to talk about the evolution of agriculture, right? If you go back to early 1800s, late 1800s or early 1900s, right, agriculture was a very laborious manual process where farmers were actually producing food for their own families. Each farmer was able to produce only food for 10 people around. And evolution in technology has actually enabled significant changes in the way agriculture has evolved. So if you look at the post-World War II evolution in mechanization, right, that has resulted in significant efficiency gains in agriculture. You can see in this graph how much the yield in terms of bushels per acre has improved. And if you look at the Ag 3.0, right, it's all because of compute, data, and simulations, data-driven decisions. I wouldn't say Ag 3.0, but we're actually transitioning from Ag 3 to Ag 4, where AI and gene editing is going to play a big role. Now, this slide just explains about Kotava. It just basically tells you that Kotava is a big pure play agriculture company with presence all over the world with a lot of revenue and good market cap. Now, I want to take an example and explain how AI is impacting a science-based company like agriculture. For example, seeds is one of the main products for us, right? When we develop seeds, there is a discovery phase and there is a development phase. In the discovery phase, you work on a lot of biotech traits, and there's a biotech pipeline that you develop. And I mean, you basically look at your genes and you try to discover new traits. And in the development phase, you start with inbreds and you cross them, you develop hybrids, you test those hybrids in the field, and when you test those hybrids, you collect a lot of data in the field, and you collect that data, you use that data to take data-driven decisions about which hybrids to take to market, right? But in that entire process in development, you collect a lot of image data, you collect a lot of video data, you use a lot of sensors like LiDAR, multispectral, hyperspectral, and you use that data to take your decisions about hybrid performance in field. And similarly, in the biotech trait development, you have one example here. We have used GenAI-based protein engineering to basically discover genes that would result in 30 to 40% of the improvement in nutritional content like amino acid content in soybeans. So, which is actually a significant thing that probably would not have happened without AI. And there are countless other examples where we have used AI to basically not just deliver a better product to the market, but also better product in a shorter turnaround time. You're basically reducing the cycle time for your R&D. So you get better products with higher yield, with better disease resistance in a shorter time, all using AI. Few examples, I mean, we work with data at all resolutions, your molecular data, microscopic data, and then proximal imaging in field, proximal sensing, which is like few centimeters to few meters, and then UAV, drone data, and then satellite data. And I mean, across the scale, the sensors we use and equipment we use are, I mean, very pretty common. Your LiDAR, that is LiDAR sensors that are pretty common in autonomous driving and autonomous navigation, and you use a lot of images and sensors on farm equipment, and satellites are quite common. I want to take one specific example to explain how AI is impacting in delivering a better product. Right, so this is soybean. When you develop soybean hybrids, right, there's a condition called iron chlorosis deficiency, which basically results in loss of yield when you plant that particular seed, right? So we do plant breeding to develop or to identify hybrid varieties that don't show this deficiency, so that you don't lose yield, right? When earlier, we were using manual data, but with images, we automated and collected AI-based data, and then actually that resulted in us finding a few genes that were not possible to find with manual data, and that helped in providing better products to the market. That's all. Thank you.
Up next, Atul.
So raise your hands for those who have worked on message queues. Great. So for those who haven't, don't lose hope. In the next few slides, I'm going to show you what message queues are. So in event-driven systems, a message queue acts as a temporary storage or a buffer between the producers and consumers. Instead of sending the data directly, producers drop messages onto queue, and consumers pick them up when they are ready. This makes it more resilient and allows us to scale. So for this talk, I'm going to talk about the AWS event listener to set the context. So I was working on an existing event listener, and that's how I found out this. So the library which I've used is the PySQS listener for this project. And this is an example of code where there's a transactions listener, and this listens to the events on the queue. Then, so imagine that, so there's an AWS ECS container now where this project is deployed. So from AWS SQS, this container polls for every few seconds, that's 60 seconds, and that is how the polling happens and queuing happens. So you all would say, then what's the problem? Okay, so because of my curiosity, I went ahead and to check the metrics in the AWS console for this listener. What I found was this. Now this is a metric of the CPU utilization of that AWS container. As you can see, it is underutilized. And there are so many, events are coming, but it is underutilized. So what we can observe is single instance of a listener to process messages queue, that is sequentially. The topic of my talk is event-driven at scale, parallel event consumers in Python. So one would suggest that with that existing AWS SQS, how about we run multiple ECS containers, which will make it event processing faster? But how about we compare it first with what is the difference between the parallelism approach versus multiple ECS? So one is that parallelism is moderately complex to set it up, but the ECS will be highly complex. It will be easier to debug on single machines and require more complex setup. It will be low cost, and the other one will be higher cost. What I chose was parallelism using Python. So this is the existing code where it was using the transactional listener. There's no need to make any changes to the listener. What you can do is, the one which is above it, that is from where you start the worker itself. There, if you start with this change, wherein you use Python parallelism, that is concurrent futures process pool executor, that will make this entire process parallel, and also the CPU utilization will be improved. So there's no change on this transactions listener. What do you think would be the result? Well, the result is this. The CPU utilization increased, the number of, and we have achieved it within a single container with no extra cost. So we have achieved it, victory. That's it from my time. My name is Atul Bosle. I work at Intuit, and you can follow me on Twitter, and this is my QR code for LinkedIn. Thank you.
Thank you, Atul. Now we have Ankur.
So this one? No, I don't have HDMI.
Great. Hey, hi everyone. My name is Ankur. Assume for a moment, you work at a fintech startup, and you went to your office, and your favorite person, your manager, arrives at your desk and says that, hey, Ankur, you know what? We've to develop this new piece of software that takes a news article, and from that news article extracts a whole bunch of things. It does summarization. It extracts all the entities, like people that are talked about in the news, some organization. Then what topic is that article on? Is it about finance, politics, or so sports? Then what is the sentiment of the article? Is it a negative, neutral, or a positive sentiment? Then let's do some content transformation such that when you share this particular article somewhere, the tweet or the LinkedIn post should automatically get generated. And let's extract some facts and some question and answers from the article. So assume for a moment that you do not have any skills in AI except using ChatGPT, LLMs, etc., Gemini, etc. So, for example, this is an article. This is 1944 when the World Bank, IMF, etc., were incorporated. And so this article basically tells you how it will work. US being the primary, currency. And the expectation is that you will have a JSON which will have all the elements that were listed as part of the initial requirement. So effectively what you'll do is you'll take this article, you will write these 2 lines saying that, hey, analyze this news article and extract all the information below, and I want this information in this particular structure, which is essentially the JSON in front of you. So you can write a raw prompt, which will have your news article, the JSON that you're expecting, and the instruction of how to analyze it, and off you go. But in reality, if you actually take this to production, you'll learn a whole bunch of things in terms of, let's say you get a new requirement, and the requirement is your second favorite person, your product manager, telling you to add few more things. What are you going to do? You're going to take the raw prompt again, you're going to start modifying things in that, and then you're going to pray that it's going to work and everything would be fine. But when you take things to production, you realize that changing requirements, model behaviors, switching from one model to another, all these add up to a lot of errors that come, and then you have to do the analysis and you start changing the prompt that you wrote. This process is quite brittle, and this is where DSPy comes and shines and sort of makes it systematic. There are 3 components to DSPy: signatures, modules, and optimizer. Given it's a 5-minute talk, we'll talk about signatures and modules. Signature is a spec, just like you write a function, right? It takes an input, gives you an output, and there's a bunch of logic that will run on the input to give you the output. That's pretty much how you can think of DSPy signature as an analogy. So remember the prompt that we just talked about? This is how you would write it if it was in DSPy. You would inherit the DSPy signature class, and you'll just create the input fields and the output fields that you're expecting and give the instructions. That's it. And when you execute this class, it'll generate the prompt for you, get you the response, and give you back in the object that you're looking forward for. So right here, you can see the article text is a string type, and it is DSPy input field. And this is the instruction, that the full text of the news article to be analyzed. And these are all the output fields that you're looking at, which we showed in the initial requirement. One thing worth noting, you look at the doc string right here, this holds significance in DSPy, because this is the instruction that you're giving to DSPy to generate your prompt, and this factors into the prompt generation. This, along with the fields, and the prompt is created for you. And that process is, like you can just do DSPy inspect history 1, and you can see the prompt that was generated. So this was how you structure and create prompts. Now, we all know that when you work in production, most of the problems are complicated, and you're writing hundreds and thousands of lines of code. There's a whole bunch of programmers working in it. You want to make sure things are modular so that multiple people can work, you can extend it easily, and it's maintainable. And this is where modules come into picture. So what I've done effectively here is for each of the things that, so you can break it down, and you can just compose a module right here, right? So you've got all the individual signatures, and in forward, you can execute all of them one by one. And this is how you can bring modularity. So that is it, and do subscribe to dspyweekly.com. Thank you. Bye.
Thank you, Ankur. And just to make sure everyone is aware, you can still submit lightning talks on the website. You can fill the form up in pre-talks, and if selected, you will be called by tomorrow's deadline, which is, I think, 1 p.m. So it is still open. You can still do this tomorrow. And this was the last lightning talk for today. Let's have a round of applause for all the lightning talk speakers who pulled this off in 5 minutes. Thank you.